Section 2, we will discuss graphing linear equations in two variables. To start, let's define what a linear equation in two variables is. A linear equation in two variables is an equation that can be written in the form ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. One can be 0 or the other, but not both at the same time. This form is called standard form. It's also important to know that the graph of a linear equation in two variables is a straight line. Now, in order to form a straight line, this is important to know, you must have 2 points. If you do not have at least 2 points or two ordered pairs, you cannot form a straight line. Not a unique straight line anyway. Let's try an example. For the given equation, find 3 ordered pairs by completing the table. Then use the ordered pairs to graph the equation. So we're given the equation x plus y equals 4. We're also given a table with missing coordinates. So just like in the last section, let's go through the process of substituting known coordinates to find the unknown coordinates. So we first start by substituting x equals 2. So we put 2 in place of x. That gives 2 plus y equals 4. We isolate y by subtracting 2 from each side. That gives us y equals 2. We go to the next set of coordinates, and we see that we know the y coordinate, but we don't know the x coordinate. So we replace y with 1, and that gives us x plus 1 equals 4. Subtract 1 from each side, and x equals 3. And last, we are given the x coordinate of 4 with an unknown y coordinate. So we replace x with 4, and that gives us 4 plus y equals 4. We isolate y by subtracting 4 from each side, and that gives us y equals 0. So think of this table as just a collection of 3 ordered pairs. We have 2, 2, 3, 1, and 4, 0. Let's continue this example on the next slide so we can graph the equation. So using the information in the table, remember these are 3 ordered pairs. Let's first plot 2, 2. So we start at the origin where the x-axis and y-axis intersect. We first move 2 units to the right, then 2 units vertically, and we place the point 2, 2. Now starting over, we go back to the origin and we plot the next point. The x value is 3, so we start at the origin, we move 3 units to the right, 1 unit vertically, and then we place our second point. Make sure not to place a point until you've gone however many units you need to in the x direction and y direction. So for the third point, we start back at the origin, we move 4 units to the right, but because the y value is 0, we don't move up or down. Once we have plotted at least 2 points, and in this case we plotted 3, once we've plotted at least 2 points, we connect those points, but since we have a line, that line should continue forever in each direction. So we put arrowheads at the end. Here's another example. Let's first complete the ordered pairs so that each is a solution to the equation. And then just like in the last example, we will graph the equation. So in this case, we have 3 ordered pairs, and in each ordered pair, we know the x coordinate. Let's first solve for each y coordinates, and then we will graph. In the case where x equals 0, we will replace 0, and we will put 0 in the place of x. So y equals 1/4 times 0. Anything times 0 is 0, so y would equal 0 in this case. In the case where x equals 4, again, we replace the x value with 4. So y equals 1/4 times 4. In case you don't remember, anytime you multiply a fraction and a whole number, it's easiest to write the whole number as a fraction and then multiply numerators and denominators. 1 times 4 is 4, 4 times 1 is 4, and 4 over 4 is equivalent to 1. So when x equals 4, y equals 1. And we can go through the same process when x equals negative 4. So we replace x with negative 4, y equals 1/4 times negative 4. And I'll go ahead and write this as negative 4 over 1. Multiplying numerators and denominators gives us negative 4 over 4. And once that is reduced, y equals negative 1. So now we have filled in our table. Let's go to the next slide and use these 3 ordered pairs to graph the equation. So starting with the first point, 0, 0, I just want to remind you again, this table just shows us 3 ordered pairs. So we start with the first, 0, 0. And if you remember, 0, 0 is exactly the origin. We don't move any in either direction. We then go to our second point, 4, 1. So starting at the origin, we move 4 units to the right, 1 unit up, 1 unit vertically. We'll place our second point. For the third point, again, we start at the origin. Now, because each of these are negative, we will move the opposite directions. Negative 4, we move 4 units to the left. Negative 1, we move 1 unit down. We place our third point. Once we have our points placed, we would draw a line that intersects or passes through all 3 points. And mine will be horribly crooked. The nice thing about using MyMathLab is you will not have to draw crooked lines. Let's now try to graph an equation when a table with partial coordinate values is given. In the last 2 examples, we were given that table. In this example, we will have to create our own. So let's graph the linear equation x minus y equals 5. Now, in the case where a table is not given, it's not already present, we must fill in the table with our own coordinates. Just like in the tables we saw before, we can only choose an x value or a y value. We cannot choose both simultaneously. We choose one is fixed, and then we use the equation to find its counterpart. For instance, let's say that x equals 0. If x equals 0, we replace x with 0 in the formula. So 0 minus y equals 5. Anytime you see 0 being added or subtracted to a number, we just cross through it. Please don't add or subtract 0 to both sides of the equation. 0 is an empty quantity. That gives us negative y equals 5. So we divide both sides by negative 1. The negatives cancel on the left-hand side. We have y equals negative 5. So we are finding our own values and then filling in the missing coordinates that are created. Let's try to plug in another value for x. So let's choose the x coordinate 1. We cannot choose a y coordinate. We must use the equation to solve for the y coordinate. So if x equals 1, we replace x with 1, and we have 1 minus y equals 4. Oh, trying to skip ahead. That's not copying down the equation correctly. 1 minus y equals 5. We subtract 1 from each side. On the left side, the 1's cancel, leaving us with negative y equals 4. We now divide both sides by negative 1. On the left side, the negatives cancel, and we have y equals negative 4. Now, in the last 2 examples, we found 3 ordered pairs. But remember, a unique line is chosen by finding 2 points. So once we find 2 ordered pairs, that's more than enough. Actually, it's exactly enough. So let's write those ordered pairs from the last slide, 0, -5, 1, -4, just so we know what we're plotting. And once we plot these 2 points, we will draw a line that goes through each of those 2 points, and that will represent the equation x minus y equals 5. So starting with 0, -5, we put our pencil at the origin. We don't move any left or right because the x-coordinate is 0, and we'll move down 5. And since we've gone in the x and y direction, we put the point. For the second point, 1, -4, we go back to the origin. We move 1 unit to the right, 4 units down, and we place our second point. Now once we have 2 points, we draw a line through those 2 points as best as you can. And that line represents the equation x minus y equals 5. Let's try another example where a table is not given. Here we have the linear equation 5x minus 2y equals 10. Again, because a table is not given, we have to create our own. Now I'll start the same way. Let's try to use the x-coordinate 0. It's nice to use small numbers when possible. You don't have to plug in anything extravagant. If x equals 0, then we replace x with 0 in the equation. Once we do so, 5 times 0 is 0. And anytime we have 0 next to another quantity, we're just going to cross it out. That leaves us with -2y equals 10. We then divide both sides by -2. On the left side, the -2's cancel. We're left with y equals -5. So we have our first point, 0, -5. Now instead of finding another x-coordinate, let's say our y-coordinate equals 0. Again, it's okay to choose x or y, but we cannot choose both simultaneously. So if we choose y to equal 0, we put 0 in place of y in the equation. 2 times 0 is 0. And anytime we have a 0 next to a quantity or being added or subtracted to a number, it's not going to change the other number. We bring down what remains. We have 5x equals 10. Let's divide both sides by 5. On the left side, the 5's cancel, and we have x equals 2. So we now have 2 ordered pairs, 0, -5, and 2, 0. Let's write those down. 0, -5, 2, 0. I'm just copying this information from the last slide. Let's plot each of these points, draw a line through them, and that will represent the linear equation. Again, 0, -5, we start at the origin. We don't move any to the left or to the right because the x-coordinate is 0. We then move down 5, and we place our point. For the second point, 2, 0, we start at the origin, and we move 2 units to the right, 0 units up or down, and place the point. Now that we have 2 points, we draw a line through those 2 points. Make sure to put arrowheads at each end, representing that that line should go forever in each direction. The next 2 examples represent special cases. Now we want to graph the linear equation x equals -4. Again, we don't have a table that tells us which coordinates we know and which coordinates we're trying to find. So we create our own table. But what you might notice from the equation is that we do not have y, the variable y, in the equation whatsoever. We only have one variable. When this is the case, part of our information is fixed. We're not given the freedom that we had before. The equation says x equals -4. This means that the x-coordinate will equal -4 every single time. So for every point, the x-coordinate will be -4. Now, because there is no y value, no y variable in the equation, y can be any number, any real number. If you want further proof of this, you can ask your instructor, but when a variable does not show up in the equation, but we still need its value, we choose any real number. So I'm going to choose 2 and 6. You can try something else, and hopefully you should get the same exact line when we go to graph. So let's go to the next slide, remembering these two ordered pairs. We have -4, 2, and -4, 6. Let's first plot -4, 2. We start at the origin, we move 4 units to the left and 2 units up. Our second point, -4, 6. We start at the origin again, move 4 units to the left, 6 units up. Once we have 2 points, we draw a line through those 2 points. Let's put an arrow at each end. And that is the line that represents the equation x equals -4. Even if you chose different values for y, you can't choose different values for x. The x value was fixed. But even if you choose different values for y, you would still have the same graph. Let's look at the special case when the x variable is missing and we have only y. Again, we start by creating our own table because the table is not given. And in this example, we are told that y equals -1. So it doesn't matter how many ordered pairs we find, the y coordinate is fixed to be -1 each time. Now, because there is no x variable in the equation, we can set x to equal any real number. This is the only situation where one of our variables can be any real number. This is not the case as we go through and try to solve when both x and y are present in the equation. So let's choose 0 and -5. Once we have 2 ordered pairs, we can plot those ordered pairs and graph the equation. So we start by plotting 0, -1. We move 0 in the left, right direction, in the x direction, and we move down 1 unit. For -5, -1, we start at the origin and we move 5 units to the left, 1 unit down, and we place a point. Once we have 2 points, we connect those 2 points, draw arrows at each end of the line, and that is the graph or the line that represents the equation y equals -1. Make sure that you find at least 2 ordered pairs for each equation, and be careful as you graph.